because it is based on the periodic table. Okay, so here is a rough sketch of the periodic table. And we're finally going to understand the shape of the periodic table. It's S, P, D, F. You can fit 2 electrons in an s orbital, and there are 2 columns over here on the left. You can fit 6 electrons in p orbitals, and there are 6 columns. B, C, N, O, F, neon. From boron to neon. There are 10 electrons. There are 5 d orbitals. You can get 10 electrons in there, and this right here is 10 columns wide. There are 7 f orbitals, so you can get 14 electrons, and guess how many? There you go. And that's coming from right here, after 6s and 7s. Isn't that nice? So all you have to do to figure out what orbital comes next is just follow the periodic table element by element. So hydrogen has a single electron. We're just talking about atoms, not molecules right now. Hydrogen has a single electron, so it has its 1 electron in the first energy level. The s sublevel only has 1 orbital, and that's where the electron goes. It has a single s electron. That's what that one right there means. That means it's only 1 electron. So this is N, and this is L. We don't bother differentiating the different orbitals. Okay. Next up, we have helium, which has 2 electrons. And they both go in the 1s orbital. Next up, we have lithium. It's the 3rd element. 1s2, 2s1. Okay, its first 2 electrons go in the first energy level. Its 3rd electron goes in the 2nd energy level. N equals 2, L equals 0. Okay. And we know that because we can just look right at the periodic table. So here's hydrogen over here on the left. Okay. That's our first electron. Our second electron is helium. So that's 1s1 and 1s2. Then we come down to the second row of the periodic table. 2s1. 2s2. Now, over in boron, we're in the p block. 2p1, 2p2, 2p3, 2p4, 2p5, 2p6. So that is how this particular method works. The row of the table equals N. And then, what block are you in? So the row of the table tells you N, the block tells you L. So then 3s, 3p, 4s, 3d. Okay, that's something you have to remember. When you go into the D block, your N drops by 1. Similarly, if you're filling in the F block, your N drops by 2. That's an unfortunate difficulty, and it's unavoidable. It's just what you have to do. You just got to remember 4s, 3d, 4p, 5s, 4d, 5p, 6s, bing, 4f, 5d, 6p, 7s, 5f, 6d, 7p, and so on. The reason we don't really need to worry beyond the 7th row is because after uranium, all of the elements are man-made. Highly radioactive, highly toxic. Most of them only exist for a tiny fraction of a second. We won't be dealing with most of those. We won't be dealing with the F block really in general, because things there get kind of messy. All right. So just remember the periodic table. Okay. So let's go ahead and draw it again. N equals 1, N equals 2, N equals 3, N equals 4, N minus 1. We have our F block, N minus 2. S, P, D, F. So with that in mind, we can do our electron configurations and our orbital filling diagrams. Okay, our electron configuration I've already shown to you. Hydrogen is 1s1. Okay, that shows you all of the electrons present in hydrogen. It's one electron. Okay, sodium. Okay, we start with 1s. We're going to end down here at 3s1. So 1s2, 2s2, 2p6, 3s1. So 1s2, it has two 1s electrons. It has two 2s electrons. It has 6 2p electrons. And finally, a single electron in the third energy level, S sublevel. And then similarly, we get iron. Iron has a total of 26 electrons. That's another way of doing this. So 26 electrons. So 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d6. So that's 2, 4, 2 plus 2 is 4, plus 6 is 10, plus 2 is 12, 12 plus 6 is 18, plus 2 is 20, plus 6 is 26. So that's another way of doing this, just counting the electrons, if you're good at remembering what sublevel comes next. So you have multiple possibilities. Now, here's the thing. What's the electron configuration of lead? Well, lead, Pb, is down here. It's down in the P block. It has 82 electrons. It's on the 6th energy level. So this will take a while. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, 4p6, 6s2, 4f14, 5d10, 6p2. Dang, that's a lot of electrons. And I gotta be honest with you, we don't care about most of these electrons. There is an easier way to do this, and we'll get to that in just a little bit. But first, I want to show you orbital filling diagrams.